Hello, so we've got 49 people in the chat here. If you do want to ask questions, just down in the description below, you can join, there's a link to join the Discord chat and we'll ask questions during the feed. If you don't mind, if you can like the page, subscribe to us, and you can also link to us on, follow us on our social media, and even donate to the Observatory on Patreon. That would be fantastic as well. Well, we've got an issue. The sky's a little bit cloudy, so again, we're going to have to do a Plan B night. So we'll need to make sure that whoever's doing the rain dance isn't doing it anymore. So hopefully next Saturday is going to be a lot better. I will be doing a public talk on Wednesday night about the Cassini mission to Saturn. So that will be at 7:30 on Wednesday if you want to join in. Easiest way to do is just go to perthobservatory.com.au, and we've got a panel there with each of the links to the pages as well. So we're going to start off tonight with the Tarantula Nebula. So this is the one of the biggest nebulas we've actually seen, and for those of you who might want to know, this program here is called Stellarium. It's really good. We use it to find out what's up in the sky. You know, later on, we've even had the police call us and asking for what the conditions were at sunset, so with that we can even show them what it would be like as well. So it's free. You can actually download it from the Stellarium site. It's STELLIARIUM. There's free versions for the Android, the paid version for iPhones, but it doesn't have ads. The free one for Android does, but there are paid apps where you don't get ads as well. But the desktop version is free as well, so you can go back and forward and back in time as well. So where we're looking tonight is just in here. So this is the Tarantula Nebula right here. So if we zoom in, you'll actually find that it's in the Large Magellanic Clouds. So this is a dwarf galaxy that's orbiting our galaxy right here. And this is about 160,000 light years away from us. So that light's traveled 160,000 years to get to the to Earth. And when you look through it, it's a massive nebula. It's 700 light years across, and so if you were to bring this to the same distance as the Orion Nebula, which we had a look at in the last stream, that's about 1,344 light years away from us. So if you brought that to the same distance, it would take up about 60% of our night sky. It would actually outshine Venus. And it would cast shadows on Earth at night. So it would be an absolutely spectacular sight. It's got a star cluster just in the middle, and so this is a shot we took a couple of Fridays ago. You can kind of see why it's called the Tarantula Nebula. So you've got the body of the spider and the legs coming out. You can see here. So there's the head. Ooh, go back. You can have the head, the body here, the legs coming out. It's also called the True Lover's Knot as well, and the Great Looped Nebula as well. We've got here, in the center here, you've got a massive big star cluster, and that's about 35 light years across, and it's got a couple of thousand stars as well. So it's pretty massive, and it's a reflection and an emissions nebula as well. So you're actually seeing light from those main stars hitting the dust and gas, and causing that dust to gas and gas to glow. but it's also reflecting the dust. That light's reflecting off the dust and coming back towards us as well. So it's a pretty spectacular nebula. It's a star-forming region. So think of this as a star nursery. There are a lot of stars that are going to be formed here. There's actually one thought that this might actually end up being a globular cluster, which we showed you last week, Omega Centauri. So these really, really old stars tightly packed in. The dark, there was actually a supernova on the 23rd of February on 1987 to herald my birthday, my first birthday. That was actually SN 1987A, and that was the closest supernova that we'd seen, and the first naked eye supernova that we'd be able to see since the invention of the astronomical telescope in 1609. Usually galaxies like ours will have a couple of supernovas during the century. Our galaxy's been fairly strange in the fact that we actually haven't, before this one, we hadn't actually seen, or even this is outside of our galaxy, we haven't actually seen one for about 400 years or so in our actual galaxy. So it could be that it's just on the other side of the galaxy and we haven't been able to see it. But it is quite unusual. We see a lot of our spiral galaxies like ourselves that have a number of supernovas going through, exploding throughout the centuries, and yeah, it's just very unusual. This is the furthest thing that we can actually show you that's in the night sky at the observatory that's not a galaxy. It's quite special, and on a dark sky night, it's pretty amazing to have a look at. So we've got a couple of questions here from Troy. Can you see in gamma ray and X-rays using this app? I don't actually know. It's the Stellarium. There might be features. You can actually write scripts. It's all open source, so you could possibly change the background for that. Also, we've got one from MR Thundy asking how many stars are in the Milky Way. There's a rough estimate of about 100 billion stars as well as in our galaxy. Andromeda's the biggest galaxy in our local group of galaxies. It's got about it's about twice the size of us and has about 200 billion stars as well. Why is it purple? That's because it's the hydrogen. So this was taken with our Nikon D810A camera. So you're actually seeing the hydrogen here and the dust from it lighting up. So it will, as you do long exposures, depending on also on the exposures as well, you go from when you just look at it with your naked eye, you can when you look through the eyepiece, it will actually look like this bluish, greenish glow color, and then as you go through with your exposures, you'll go from red to purple, and then if you do lots and lots of exposures, where some of these photos that you see on the internet, they're talking about 5, 10, 20, I've even seen one of the Orion Nebula where they've taken over 1,000 hours of exposures of these objects, and you get to see the full structure. One thing you'll notice with Hubble, Hubble has some interest, has different filters, so they don't normally show RGB. They use a specific filters for, so green I think is oxygen, yellow is for sulfur, and red is for hydrogen. So you'll get a lot of greenish photos. So if you can remember from the Pillars of Creation, you'll notice there's a lot of greeniness in that original photo from Hubble, and that's because there's a lot of oxygen in there. as it's the European Southern Observatory. They've got a different set of filters for when they take photos, so their images will look different compared to, in terms of colours, than what Hubble does. There's actually great debate at the moment about what the colours and filters they'll use. The filters matching the colours for the James Webb Space Telescope if it ever goes up. So what makes this a star nursery? So what you're seeing is the nebula is made up of dust and gas. So mainly in terms of the gas, we're looking at hydrogen and helium, and the dust are silicates as well. So what will end up happening is you'll get as the nebula settles down, you'll get these things called block globules, and here you're seeing small clouds within the actual within the nebula that are housing star formation. And so what you'll actually see here in this image, this video here from Matt Bate is, and I showed this last weekend, but you're seeing the nebula here itself actually actually collapse and start forming stars. How do you view it? Well, you can actually view it with the if you're out in the country, you can actually see the Tarantula Nebula with the naked eye. You can see it with binoculars as well. Telescopes are really good, and the bigger the telescope, the more detail you'll get out of it. If you definitely go out to the country, places like York, or even Lake Leschenault here in Chidlow, if you go out to these country towns, there's some really nice spots where you can camp out. There's a really good website by Astro Tourism WA. It's run by Carol Redford, which is actually trying to promote astro tourism in our country area as well. So hopefully once this coronavirus has all settled down, we can go out and do some viewing. So you can actually start seeing in the video here that there is actually stars now forming, and these little tight knots as well. Troy, you can see it if you do some astrophotography. It's a very faint object, but you can actually see the Lagoon Nebula and the Trifid Nebula, which are quite close to the American Nebula, where the actual pillars of creation are. When was the nebula first? It was discovered by. It was a Frenchman actually. When they came down to the southern hemisphere, that's when it was actually discovered, and basically rediscovered by the Europeans. So it would have been around that time of the 17th, 18th century was when it was found. Padre wants to know why Pluto isn't a planet anymore. Oh well, back in 2006. The International Astronomical Union got together and basically nutted out what a planet was going to be. And for about 24 hours, we actually had 12 planets. And then the people who didn't want that many planets, they argued that we needed to do a revote, and so they voted again, and unfortunately Pluto, Eris, Ceres, Vesta and a few others got kicked out, and they ended up and so the reason was they ended up, when they voted, they were voting on the rules, and the actual rules ended up being to be a planet you have to orbit the sun. You have to be big enough to pull yourself into a sphere, and you have to clear out your local neighbourhood of foreign objects. So Pluto meets the first two rules. It just doesn't meet that third rule. It orbits in what's called the Kuiper Belt. So we've heard of the asteroid belt. It's not like the Hoth asteroid belt in Star Wars: A New Hope. but there's a lot of rock in there, but it's safe to send spacecraft through. But there's another belt just past Neptune called the Kuiper Belt, and this is full of icy bodies and that. So unfortunately, Pluto still really orbits in there and hasn't cleaned out its local neighborhood of those stars. So unfortunately, it isn't a planet, but it's called a dwarf planet. I kind of personally think back in the day when I was reading, I thought, well, maybe they should just make it a subcategory, like we have ice giants, a subcategory of the gas giants as well. Okay. Are there different colours surrounding stars dictated by the gas like hydrogen as well? There's actually a really nice feature called Rhoophae around where Antares is, and it's actually different colours, and that's because the stars in that dust are different colours. And so Antares is a red giant. It's coming super giant actually. So it's coming up to the end of its life. So it's orange, and so the dust around there is actually a lot of is coloured orange. There's a couple of blue stars in Rhoophae as well. So the areas around those stars are blue, and there's a red star as well, which lights up red. So not everything is always going to be red, but hydrogen does tend to be that purplish red in the night sky. Cato's daughter Abby would like to know where the gas in the nebula comes from. Well, when you had the Big Bang, you ended up, it was actually opaque. You couldn't actually see anything. There was a super plasma basically, and that settled down and formed into your quarks and then into your atoms. So the very first elements that were actually made was hydrogen, and because it's the first element of the periodic table, and so there was a lot of hydrogen, and that formed the very first stars. And from there, from the first generation stars, we got helium, because stars form hydrogen to helium, and then we got more elements as the stars died, and we got, even like gold comes from mergers of two neutron stars. So there's some pretty fancy science going into creating gold. So if you've got gold rings or necklaces, it's pretty amazing. Well, so the next target we'll have a look at is the next stage after a nebula. So we're going to be going to what's called M46. Now the M stands for Messier. So this is named after Charles Messier, who it was a French astronomer who created a catalogue of objects that he saw that were objects that they thought were comets but weren't comets. So he wanted a catalogue so that they could work out, okay, that's, you found a comet? No, don't worry, that's in my catalogue, that's a star cluster. So where we have here is, if we look to the west at the moment, and we find Sirius, and just slightly up from Sirius we have the two clusters called M46 and M47. It's actually pretty easy to find M47, and then you can go from there to M46 right here, and this is what it looks like. Got some planetary disks in the nebula. So this is M46 here, and this is M47 right here, and this is it here. So you can actually see that we have here a open star cluster, and this is what happens after a nebula forms. So the nebula has used all the dust and gas it can and anything that's been left over has been blown away by the wind from these stars. We have a thing called solar wind that comes off our star, and it's always there. It does change speed every so often, but it's constantly blowing. So when we don't, you still can get auroras in the north and south pole from the solar wind. But the bigger the star, the stronger the solar wind is, and so with all these stars, you can actually blow away. It's actually it's got a planetary nebula as well, which you can just see in the top here, right about here. And this is a little ghostly. It's a star that has unfortunately died, and it's a star that's been very much like our own as well. It's 40 light years away from us, and it's 40 light years across, and it's at a distance of about 5,500 light years away from us. It does contain about 500 stars, and they're about 300 million years old. So, yeah, for stars, that's quite young. So you're talking about toddler to beginning of primary school if we're talking about kids. They're pulling away from us. We've done some distance measuring and seeing whether they're blue shifting or red shifting. So red shift, they're actually moving away from us, or blue shifting, they're coming towards us. That's where the light, when you've got a spectrum of light, so you go red, you've got the rainbow, and you can actually see the light, and it's you have these things called Fraunhofer lines, where you can actually see the elements from that make up that light, and if they're tailed to one side to the other, you can actually denote whether it is moving away from you or coming towards you. So we've been able to work out that this cluster is actually moving away from us at 41.4 kilometers per second. So that's almost like going from the observatory to the CBD in a second. That's how fast they're moving. As I said beforehand, they're really easy to. It's easier to find with binoculars than our finder-scopes on the telescopes. So if the telescope isn't behaving itself and just slightly out, usually it's good to get a pair of binoculars and just try and work it out with a green laser. Charles Messier actually discovered it just after he published his first catalogue. So M1 to M45 it was his very first catalogue. So the Crab Nebula in Taurus, all the way to the Pleiades cluster, which we had a look at last Saturday. Messier said of his discovery, a cluster of very small stars between the head of the great dog, Canis Majoris, and the two hind feet of the unicorn, determined by comparing these clusters with the star 2 Navis of the 6th magnitude, according to Flamsteed, who is referring to John Flamsteed, the very first royal astronomer of England, who was commissioned by Charles II to turn Greenwich Palace into the Greenwich Observatory. And highly recommend, if you go to London, have a look. One cannot see the stars, but with a good refractor, referring to a refracting telescope, the cluster contains a bit of nebulosity as well. But it wasn't until John Herschel in 1833, before they actually found the Planetary Nebula, and he referred to it as the brightest part of the very fine, rich cluster, stars of the 10th magnitude, which fills the field, with a cluster of the northeast edge in a fine planetary nebula. And so the actual nebula itself, we've actually seen is expanding, and the glowing shell of ionized gas is actually being ejected from a red giant star. This nebula is different from the Tarantula Nebula. So where the Tarantula Nebula is a star-forming region, this is just the end of this is the gas that's escaping off a dying star. So it might take a little bit to actually form any stars, if any. They're very. It's actually unrelated to the cluster. When we do actually do measurements of this nebula, it's actually about 2,900 light years away from us. So it's actually in the foreground, and so it's a nice little thing to have a look at. It will only last about tens of thousands of years before it will slowly dissipate, and you'll really have to do a lot of long exposures to even find it. But it is interesting to see, and one thing, if you have a look on if you Google SN 1987A, you can actually see the gas coming off, because they've been recording it since it's happened, and it's pretty interesting seeing those shells moving away from the star. So we'll have we've got some more questions here. Where is it? So, will the small Magellatic Cloud and the large Magellatic Cloud ever collide? Well, eventually collide. Actually, they've already collided. There's actually a magnetic bridge between the two. The small Magellatic Cloud, both are dwarf galaxies that are orbiting around our galaxy. And the large already went through the small, and there's actually a magnetic bridge between the two. They're sharing stars, dust, and gas, but eventually they think maybe that's what's warped each other. The small was actually a planetary nebula. Sorry, not a planetary nebula. It was a spiral galaxy before it got distorted. But eventually, probably within 2 billion years or so, they should actually be consumed by the Milky Way. The Milky Way has actually consumed about 10 to 11 galaxies already to get them to this point. So yeah, unfortunately, galaxies are cannibals. How do stars die? Well, they run out of hydrogen. And so what ends up happening is you'll see some of these stars won't last while the cluster is apart. Eventually, these stars will go off in their own way, and that will take probably a couple 100 million years. But a star's life is determined at the very beginning, by how big it is and how much hydrogen it has. The really big stars are very uneconomical. They last tens to 50 millions of years, where the really small stars, they last. There hasn't been enough time in the galaxy or in the universe for the very first red dwarfs to die. Our sun's middle of the road. It's had about 5 billion years, and it's got about another 5 billion years to go. So it's middle-aged, which is good, because you don't want a star you don't like to be orbiting a star that's very young or very old. They're both very active. Are we aware of any stars that we estimate will go supernova in our galactic neighborhood? Well, there's a couple. You might have seen in the news at the beginning of the year that we thought maybe Betelgeuse was going to blow up in Orion, and Orion was going to need a shoulder reconstruction. But unfortunately, it seems to be brightening, so it might have just had an episode where it's towards the end of a star's lives. There's trying not to get too technically here. They think it could have just either been that there was some dust moved in front, or there were convection cells, which you can on our sun. The convection cells are about the size of Texas, so there's a lot of them, heaps of them on the surface of the sun, and they transfer heat back and forth between the lower levels and higher levels. With red giant stars, when they get to the end of their lives, they can actually have massive big ones. What's my favorite, personal favorite constellation, and why? I think Orion or Scorpio, and it's because they actually look like what they're meant to be, and they're quite easy to see, and you can point out and each of the stars have some really interesting stories as well. With the Orion, you've got the saucepan, which you can make up with with a few stars in the Orion Nebula. Troy says, do you know when the Tesla car is going to make it to Mars? Well, actually, it probably should have already. It should possibly have made it to Mars's orbit already, and it should be coming back. I think it's going to make a close orbit of the Earth in 2022. How many stars are identical? Super sexy star stuff. They think there's about 500 stars. Okay, what's the difference between a meteor and a meteorite and a comet? Well, a meteor is something that burns up in the atmosphere. A meteorite is a piece of rock that actually makes it through the atmosphere and hits the ground. And a comet is basically a big dirty snowball. So it's mostly made up of ice, bit of dirt. You can actually make a comet here on Earth as well. I won't tell you exactly how to make it because it involves dry ice, but it is pretty interesting to make. Super Sexy Star Stuff also asks, M46, is it connected to a cluster or is it merely in the foreground? Yeah, so that was the nebula. Yes, it is a foreground object. What does Solarwinds do? How does it interact with other objects? Well, so it's photons of light, radiation called charged particles, and so they're blowing off. The reason we call it a solar wind, the technical term is a solar corpuscular wind, and it acts as it's these streams of particles that are coming off the actual sun, and it almost acts like a wind. You can and it's always there. So it interacts with our magnetic field. The reason you'll see auroras is because if you've ever seen a barred magnet with some iron filings where you can actually see the iron filings will move along the magnetic field line of that magnet. Think of that as our Earth. Our Earth has a magnetic field, so north and south, and it can actually flip. We've seen in the history of the Earth that it's actually flipped. And so there's magnetic field lines. And it's because we've got a quite unusual large core from what we think was the impact between a planetoid called Theia, which was about the size of Mars and Earth, which created the Moon. We've got a large iron core in the center which spins, and that allows us to have a magnetic field. And so that wind will actually hit our magnetic field line, or magnetic field, and get deflected by the magnetic field line. But some of that material comes along, some of those charged particles come back along the lines to the north and south pole, and when it hits oxygen particles it can glow green and red. If it hits nitrogen particles it can glow pinks, and purples and blues as well. My grandma is skeptical that can you please explain how that we did land on the moon. We did land on the moon. Easiest way to find is that they've actually the astronauts left these panels so that you can actually send a laser beam. Observatories can send a laser beam there and record how fast the moon is receding away from the Earth, and it is moving away from us at about 4 centimeters per year. It's nothing that's going to be massive. Like by the time the solar system ends, it will still be connected to us. But there's a really good podcast series by the BBC called 13 Minutes to the Moon that actually deals with the last 13 minutes of Neil Armstrong and Buzz landing on the moon and what it took to get everything working for that 13 minutes. It's done by Dr. Kevin Fong, and there is actually a season 2, and he's currently doing it at the moment. There's 5 episodes, and it's about Apollo 13 as well, because this year is the 50th anniversary of Apollo 15. So the stars formed. If you if you go back in this live stream, you'll see a video of the nebula collapsing, and in the collapse, the actual stars, the dust particles and gas particles come together as well. What is the highest magnification there? They're all, apart from our astrograph telescope, which was the very first telescope for Perth, they're all reflecting telescopes. So it's the magnification is actually done by the eyepiece. So I think we've got an 11mm eyepiece, which can really bring stuff up. How often are stars forming? Well, they're always forming. It depends on what type of galaxy these nebulas are in. The spiral galaxies are young to middle-aged, and they'll have a lot of these nebulas where the actual stars are forming. Where the big elliptical galaxies, which you'll see, they're galaxies that have had lots of mergers, used all the dust and gas to actually collide. Okay, we'll just leave it there for now, and we'll go back. The next one we'll have a look at is the 8-burst galaxy. And the 8-burst galaxy is so this is actually it's a southern hemisphere object. So if you're in the northern hemisphere, you won't have actually seen this. But let's have a look here. We'll go type in NGC 3132. And that's where it is. So we've got, if we scroll out a little bit, we've got the Southern Cross right here, and then we've got Eta Carina, which we had a look at last week, and you can go back and actually see it on our YouTube panel if you missed last week. But just slightly up here from the Eta Carina, we have the 8-burst Planetary Nebula. So very much like the Planetary Nebula that we saw in the foreground of M86. This is another star that's blown up, and it's expelled the gas from its outer layers. So this is what's going to happen to our sun as well towards the end of its life. It's located in the constellation Vela, which is the sail. So there used to be one massive big constellation called the Argo Navis, which was the ship that the Jason and the Argonauts used to go out and find the Golden Fleece. But that was broken up in, I think it was 1920, and so they broke it up into its individual parts. So Puppis is the stern, Vela is the sail, and the rest of it is the Carina constellation. And so in this case, this is what's called a nova style event. So a supernova is where the star blows itself to bits. When our star will experience what's called a nova type event. And so the core of the star will collapse, and from that the outer layers will go off in this shell. And you can actually see here we've got some bluish in the middle, and we've got the red ring of the hydrogen being expelled out. So this object was actually discovered by Sir John Herschel in 1835, using the 18-inch telescope in the Cape of Good Hope. There's two stars in the very middle, and so this is taken by Hubble, and you can kind of see that the greenish and the yellowish appearance that usually denotes that it's a Hubble image. And you can see that there's two stars here in the middle. The dim star right here, this is the star that's caused all this. It went nova, and now it's a white dwarf. It's extremely hot. It's over 100,000 Kelvin, and it produces a massive amount of ultraviolet light that keeps the actual nebula glowing itself. The 8-burst nebula's name actually comes from the fact that it's unusually elongated, and you've also got this little dust trail here, and that forms figure 8. So it's always interesting. There's another. They're really nice to actually look at. They're quite small. This one's less than a light year across. This is as 0.8 light years across. But there's some really nice ones like the Ghost of Saturn. I really like the Eskimo Planetary Nebula as well. But yeah, the reason they're actually given the name planetary nebulas were they thought when they first found them, they thought they might actually be planets because of they're usually in a circles. You can get rectangles. It really depends on how the star exploded for its shape. And yeah, it'll recede in the next few tens of thousands of years. So we're fairly lucky to actually be able to see it at this time. So yeah, it's a really nice little object, and there's quite a lot of them. And by doing a lot of astrophotography, you can actually draw out that light. So we've got a couple of more ones. So Dragon Master. So the planetary nebula is the star. When the star collapses, it will, depending on what it is type. So in our sun, the core of the star, what will happen is once it starts running out of hydrogen, the core will actually heat up, and so that it can fuse the helium that's been turned into helium from hydrogen. And so the star will start to expand, but even though the core is getting hotter, it's expanding quite a lot. So what ends up happening is that the star turns red because the core has to heat up a lot more area, but it just hasn't heated up enough. So if you have a look at a flame, and it's very much the same thing for stars. Red is the coolest of the flames. Then it goes orange, yellow, white, and blue. Our star is actually a yellow whitish star, so it's again middle of the road. So, but for stars, it's good to have a middle of the road star. It's good for life. And so it will go through, and in terms of our star, they'll have a period where it runs out of helium, and so it will get hotter as well. So it will then convert into carbon and then oxygen, and so you'll end up getting a core of a star that looks a little bit like an onion. So you'll get a layer of hydrogen, a layer of helium, a layer of carbon, a layer of oxygen, and this is how we get these elements that you learn about in the periodic table in high school. So and so towards the end, and it also takes a lot as you go through the elements. You're taking a lot less time to actually to create these elements. So by the time it reaches calcium, you only have a couple of days where it's had all this time to burn hydrogen. Then it's had half that time for helium. Then it gets lower quicker and quicker and quicker in each of these periods of time, to the point where when it gets to iron, iron takes way too much time or takes too much energy to fuse into iron. So you have about a day of fusing iron, and that's when the star loses its battle with gravity. The core collapses, and then what ends up happening is that there's a rebound, and you'll get the outer layers being sent off. That's still on the star. In a supernova explosion, they crush the star. At minimum, what you'll get is a neutron star, or if you think of your atoms, you've got protons and neutrons that make up the atom, and then you've got the electrons that orbit. Those get squeezed, and so the electrons and the protons are merged, are turned into neutrons. So you've got a star that's completely made of neutrons. And then that happens if the star is about 8 to 15 times the mass of our sun. Anything beyond that is a black hole. But there are even what called hypergiants, which are stars that if you put them in our solar system, they would expend past Jupiter's orbit, and those stars, when they blow up, they just blow up. There's nothing left of them. So it's pretty amazing. When are people going to Mars? That's from Altogether. I would probably say it will be second half of this century. There's still a lot of stuff that we have to learn. I know there's a lot of people poo-pooed going back to the moon, especially with the lunar gateway, but we do need to learn how to live in an environment where we don't have the magnetic field of our Earth protecting us. And also the good thing is that it's using a particular orbit around the moon so that we never lose communication with Earth. And it also means that you can dock there and go to Mars, and you don't lose much delta V, or you don't have to use a lot of fuel to get out of the orbit. So it's a good place to actually start off and go on. And it also means that there'll be a lander there, so you can land on different parts of the moon, and so it's a good start off place. But I think definitely going back to the moon is a good place to learn how to live on another rock, because it's really only a couple of days to get back if there is an issue, just like Apollo 13. If you have trouble on Mars, you're really there for about 2 years before you can get back. Recently named a star after a past friend. Is there a free app that allows us to augment its? Yeah, so usually the Stellarium can do it. I know the desktop version is the one where you can put in the just if I go back to Stellarium, you might have seen that when I moved to this object, there's a search field here. And so this is the object field here, but you can click on position and you put in right ascension, which is east and west, and then declination, which is north and south. Are the constellation names so tied to mythology? Are they officially recognised names by the IAU? Yes, so they are recognised. So that the IAU settled this back in 1920. So there are 88 official constellations. Most of the northern hemisphere ones are from Greek mythology. And the good actual thing about Stellarium is you can actually, in the settings, you can actually change, not that one, but you can actually change the stories and the constellations to other stories. So like the Babylonians. I think there's even indigenous culture for Australia as well. But yeah, if you there's a really good audio book I'm listening to at the moment called Mythos by Stephen Fry. And that has a lot of the stories about the constellations, and he does the actual audio book as well. So it's really good. And I think he's also done another one called Heroes. Jasper says hi from Jasper and Sam. Hi, first time watchers. Is Aldebaran that really bright star in the evening sky below Orion's belt? So it'll be off to the west of Orion. So you'll have Orion, Taurus the bull, and Aldebaran is the red eye of Taurus. And then you'll have the Pleiades cluster, which is just slightly down from Venus. So Venus is the really, really bright one, but there'll be in between Orion and Venus, there'll be a red star, and that's called Aldebaran. That's another star that's coming towards the end of the life. I wished upon a star once and it didn't come true. Why would that be? Faulty star? Yeah, I think so. This distance. So a lot of how do we measure temperature at that distance? So a lot of it is actually spectroscopy, sending that light through the prism and seeing that light, but also the color of the star can denote what range of temperature it is. Kato says hi from my 6-year-old Thomas. Hey Thomas, how you going? he would like to know how the planets are made. Well, the very first lot of planets are actually made were the gas giants. So Jupiter was the very first planet formed in our solar system, and it actually it's got a rocky core. So it's about 5 times the size of Earth, and from that, so at the very beginning, Jupiter was a rocky planet, but because it was 5 times the size of Earth, it was in the part of the solar system where you could actually, where gas and ice could form. It was able to get a lot of gas, and so there's a really good documentary done by BBC Horizon called Jupiter Ascending, I think it was, but it was based off the satellite, Juno satellite, that's a probe there, and its mission is to find out what it is, and it's absolutely amazing. It's an amazing planet. And then the last planets to form were the rocky planets. So they form from a disk that orbits around the star when it's very young, and but yeah, we're only just still trying to figure out whether our solar system is the normal solar system, or if we're an outlier. My daughter would like to know what would happen when our sun dies. Will it suck the planets into it? Well, actually, you wouldn't want to be on Earth in 1 billion years. The sun will start to expand, and so it'll get it'll get really hotter, and then as it gets bigger and bigger and bigger, it will gobble up Mercury and Venus. They don't know about Earth. It might get really close and we get completely singed and we just break apart, or it could gobble us up, or it could actually the Earth could move out as well. But as the star gets bigger, that Goldilocks zone where Earth is expands out. So you could planet hop. You could go to Mars, then you could go to Jupiter's moon Europa, and then Titan, and then even maybe Pluto in the end. But where they've all got water stored up. So okay, so we'll go to the next object, and I think we've got some galaxies. How about that? So the next one is called the Symmetrical Galaxy, and so this is right here. Where is it? Go to M1. So this has a Messier catalog number. So if we have a look here, we'll turn on it's just in between Corvus the Crow and Virgo right here, and it's very close to the same size as us, as our galaxy. It's at 85,000 light years across. It's 32 million light years away from us. So the light that we captured, the photo we captured here, that light there has taken 32 million years to get to Earth. So we're seeing it as it was for 32 million years ago. The supermassive black hole at the center is actually about 100 times as larger than our own Milky Way as well. So it's pretty impressive. It's a dominant member of a small group of galaxies called the M104 group. So again, Messier catalog, but actually this is the very first object that didn't make Messier's full catalog, but he did note that there was something there. He didn't know what it was, so he didn't put it down in the catalog. But it does contain features normally found in both spiral galaxies and also elliptical galaxies. Like many spiral galaxies, it has a strong disc shape. It's got spiral arms. It's actually got no central bar. So in our galaxy, there's a bar from 2 main arms coming off, and then there's spurs coming off those arms. where there's no central. So it would look a little bit like the southern pinwheel galaxy, M83. And it's got prominent dust lanes as well. It does have, very much like an elliptical galaxy, it has a huge central bulge that's far larger than normal. It extends about 10,000 light years either side of the actual galactical disk as well. But that dust ring is also symmetrical, so it's nice and circular. And that's where the actual star formation is happening. It contains more than 1,000 globular clusters, which is about 6 times more than the Milky Way. So everything seems to be a little bit, even though it's a little bit smaller, it's a lot more compact, and it's everything's a little bit more. It's got more of everything really, but it's also moving away from us at over 1,000 kilometers per second. And it's one of the fastest moving galaxies in our local neighborhood. As the universe expands out, stuff is getting faster and faster and faster. But there are local groups of galaxies that are gravitationally pulled together. So you will see some galaxies like the Andromeda Galaxy that will merge in about 4.5 billion years coming towards us. But that measurement was actually found by American astronomer Vesta Slipher in 1912, and that was one of the very first clues that the universe was expanding as well. So it's a nice little one to find in our 30-inch telescope. Even in our 14 and 16-inch telescope, it still puts on a good show. And when we get some chance with our dark sky nights, it's really a shame because I do such a better now that we, I was hoping to do a better job of it with our camera tonight. But yeah, so we'll do some more questions. Where was I here? So the visible black holes, this was actually, we've seen our central black hole, but the image that Sinja put up in the chat beforehand, that's of I think that one was the supermassive black hole in M87. So really at the moment they're only really looking at the supermassive black holes. You can't actually see the black hole itself because of the singularity. You're actually seeing the accretion disk here and around the black hole itself. It is actually, if you have a look at, if you watch Interstellar, it's very, they use Kip Thorne, who actually was part of this project, Event Horizon Telescope, to actually get this image. And you can see that it's very similar. The only thing that they didn't capture is the fact that there'd be more light on one side than the other side, because it's the gravity. You've got light moving down, and so at a faster speed than coming up. The back end is actually being gravitationally lensed, so it's actually flipping up. How much does the mass of a star change during its lifetime? So it will start to lose mass towards the end of the life as it starts expelling the gases. Okay, what's the Lunar Gateway? So the Lunar Gateway is a mission that's coming up. It's a international consortium with NASA, Roscosmos, and I think also JAXA and the European Space Agency. So again, think of a smaller version of the International Space Station, and they'll be able to, it'll be in lunar orbit, it won't be in Earth orbit, and they'll use that to go off to Mars and also to land on the moon. It was supposed to be set up by 2024, but I think it's now been extended to 2028. And America's plan to land on the moon in 2024. That will either be a Falcon Heavy or the Space Launch System. how come the universe expands so much that there is space in between actual objects? Because it's had about 13.8 billion years, as Carl Sagan's a billion years. So it's expanded really, really fast, and so the actual universe itself is about 92 billion light years across, but we can only see 46 billion years in any one direction. But that's the observable universe. There are stuff beyond that we just can't see and we'll never be able to see, unfortunately. So it's one of those things that you can say, people say, hey, where is the end of the universe? Oh, where did the universe start? Well, for us, it started here. For a galaxy on the other side of the universe, it started there. So the easiest, it's really hard to get your mind through. Even I find it hard. But an easy way to have a look at this is if you get a balloon, you get a permanent marker and mark dots all along it, and then blow up the balloon, and you'll see that the actual dots are expanding away from each other. What do you think? So Troy says, what do you think about meteor that's on its way? NASA says probably is going to be a close one. I think the usual culprit is Apophis. Again, the very first Galul that tried to get after Ra on Stargate SG-1 to cause us issues. But look, over the years, they've got a better estimate of its orbit, and each year it keeps on getting less and less chance that it will actually hit us. But again, it's why they're good to let you to ask the question, how's that space program going? I heard that Uranus has its own set of rings. Does that mean that Saturn is no longer the undisputed hula hoop champion of the world? Well, it's always going to be the undisputed hula hoop champion of the universe because it's got it's got those pretty rings. Uranus does have a set of rings, and guess who helped co-discover them? The Perth Observatory did. So in 1977, NASA sent its Kuiper airborne observatory out to Perth, and so it's 1977, I think I said, and it flew the route and actually captured the whole event. We were actually going to be able to do the whole thing, but unfortunately it was slightly south of us and the path. So we captured the rings at the first part, but we didn't get. We missed the actual pass of this Uranus in front of a star, called what's called an occultation. Wednesday, I think it's. I'll be doing a talk on the history of the Perth Observatory on the 22nd, and I'll go into that as well. So, so it does have set of rings and some ring arcs. Jupiter has a very faint dust ring, and Neptune also has rings as well, but mainly ring arcs, which are incomplete rings. Another question from JJB Keeper from his nephew. What is your theory, or which theory do you support of what's outside the universe? I think it's probably galaxies, and that it's I think you'll probably find as you go, if you're able to leave our observable universe, you would see more stars and all that kind of stuff. But it would be interesting to see what if there are like multiple universes, or if we're just the only one. So what I'll do is I will go to our last object for tonight, and then we'll finish off with some questions. So this is another galaxy. This is called the Centaurus A galaxy, and this is pretty cool. Is a pretty cool galaxy as well. So this is also very close. Gone a little bit too far there. This is a little. This is quite close to the Southern Cross, and it's right here. So we had a look at Omega Centauri last Saturday. That's here, and then just slightly off to the east is Centaurus A, or the Hamburger Nebula. And as you can see the halo of the actual disk of the actual central bulge is the buns, and there's the patty in the middle of the dust lane. So just thinking of it makes me want to get a hamburger. So this is about 97,000 light years across. So that's very, almost the same as us. It's 13 million light years away from us, so it's fairly close. And it's 13 billion light years old as well. So roughly the same time as that it was formed as our galaxy as well. It's an elliptical galaxy. It's the fifth brightest galaxy in our night sky, but it's extremely bright in radio. So if you look at it in X-ray or radio waves, it is amazing. So this is an image here from the European Southern Observatory. So they're using the optical light from there, plus also from NASA of the X-ray. And what you don't see in this photo is these massive big jets that are coming from the central black hole, because it's going through a starburst phase. So this galaxy has actually been collided with another galaxy. And so when this happens, is you get the dust and gas mixing together, and that causes the dust and gas to collapse and just breed stars like rabbits. Actually, that's the one thing about the Tarantula Nebula. The interactions between the Large Magellanic Cloud and our galaxy, they're causing seismic waves to go through that nebula, and it's the most active star-forming region in our local group of galaxies. This nebula in the Large Magellanic Cloud, but this is also happening here, and so there's also a lot of dust and gas that that's falling onto the black hole. So it's feeding at this time, and this is dust and gas that, in the event horizon, as it's spinning around the singularity, the magnetic field lines have actually pulled it up to the north and south pole, and it's hit the singularity and then been ejected like a rail. And this is the actual same principle, what's called a railgun, using magnetic fields to actually fire objects. So you have no propellant in the actual bullet or so, but it's expelled from the gun using magnetic field. And from the actual radio observations of these jets from over the years, we've actually found that these jets, particularly the inner parts, that dust and gas is moving at half the speed of light. So it's pretty amazing. Also, this is really this is a really nice discovery for Perth, for Australia, as it was found by Scottish astronomer James Dunlop in 1826 in the Parramatta Observatory in New South Wales as well. It's no longer there. There is a little plaque for where it was located, but it's another discovery that's been made here in Australia as well. There was actually a Type 1a supernova. So this was a star that was orbiting around another star, and the star that blew up was a white dwarf, and it reached what was called the Chandrasekhar limit. So there's only a certain amount of mass that a white dwarf can hold before it blows up, and it went off. And the good thing is you can actually use these Type 1a supernovas to measure how far the universe is once parallax we can't use parallax. And so that supernova actually occurred in the dust lane of the galaxy in 1986, and it was actually the 7th supernova discovered that year. So it's pretty, it's a lovely lovely supernova, lovely galaxy, and it's another one that we can, on a dark sky night and through our 30-inch, it looks absolutely amazing. So I'll go through and we'll answer these more questions, and then we'll finish up for the night. So we've got, okay, I paid to own a star. I just wondering how I can get a hold of it. It's nice being able to being in the sky and everything, but I'm thinking it might be best to keep it in the house, like a cool. Well, unfortunately, just the journey alone will probably you won't come back. One of my talks I've done is space is really big, and I'll do this. I'll do this one on the 29th. Called Space is Big. I mean really big, and I work out. I have the distances of objects that we show in the night and a couple extra, and then I work out how long it would take Daniel Ricciardo in his Formula 1 car to get there, it's some stupendous numbers there. But look, if you have bought stars, we have our own star adoption program, but if you send us an email, you can book on a night sky tour, and then we can show you at the end of the night. We do have to check before we can actually see it, because it could be seasonal, or or even if we can see it at all, because a lot of these stars, these websites where you can buy stars, they're using the Hubble catalog, and stars that are really, stars that are bright for Hubble can be quite dim for us. How do we know that there are things in the beyond the observable universe? Because we can actually see stuff that's moving faster than. So we're moving in one direction, and they're moving in the other direction. So they're actually going supposedly faster than the speed of light. But we're seeing. We can only see so much. So for me it's a little hard, because it's I'm still just trying to get wrap my mind about it as well. The Falcon Heavy launch is good to watch, especially the landing when you can hear the double boom. Yes, it's amazing. It's kind of funny seeing United Launch Alliance, which I think is Boeing and Northrop Grumman, who basically said it can't be done. You can never land rockets back on Earth. And Elon Musk went, watch me, and he was actually able to do it. So he's dropped the price down of rockets and the entry to space dramatically. And even now they're able to catch the fairings, which is the top of the rocket, which gets once they're in space, ejects from the rocket, and they can catch them with these big nets on boats and reuse them again. So I think they've used a couple of rockets now 4 times, and I think there's even been a 5th time. Macca's mate, I'll have a look at this after. I'll answer your question after the stream, because I'll have to have a look at it as well, because I don't particularly know that telescope. Does dark matter get absorbed by a black hole? I actually don't know. I'll have a look at that after the stream and get back to you. Rusty Cone. Do you think the idea that the Earth is the only inhabitable planet is ridiculous? No, I don't think so. I think there's enough galaxies, as the Hubble Deep Field showed. There's so many galaxies out there. It takes a lot to get life started, but life's pretty hard to kill. We're probably not going to find life like us straight off the bat. You'll probably find that it will be bacterial life, that will probably be what we find first. There's bacteria called extremophiles, which basically love places where it would be completely intolerable for us to live. So superheated water, water that's got that's acidic or completely basic. So really hot temperatures and lava and all that kind of stuff. So look, I would say we should be able to find life out there, but it's as Spock says, it's life that we don't know it. Gyroscopic says Perth can the Perth Observatory see objects on the moon from moon landings? I've heard that we can't because it's either too small or too distant. Yes, look, you can get pretty close up to seeing like craters with certain eyepieces, so a 40mm eyepiece will let you see the whole moon. 24mm eyepiece, you'll get a certain section of the moon, and as you get further down, so like 11 or 4, you're looking at certain big craters. But you can still see them. You can see the landing sites from images that NASA has taken with its lunar reconnaissance orbiter. So if you put in lunar reconnaissance orbiter and moon landings sites, you'll be able to see it. So you can actually see where the astronauts have actually kicked up the dirt as they've walked along, because the soil underneath the topsoil hasn't been baked by the sun, so it comes up a lot. It hasn't been bleached as much. Is there a double star cluster to the left? So I'm guessing you're talking about these two. This might actually be a double star, but there are two. There's Alpha Crucis with the brightest star in the Southern Cross, and also Alpha Centauri A and B, which we can see. Proxima, which is a triple star system, but you need a massive big telescope to see Proxima Centauri. But you can see Alpha Centauri A and B, so they're fairly close as well. Let's have a look. Thanks. All right, so I think that's it. So thanks very much, guys. Hopefully we'll do better next Saturday, but hopefully you will join me on Wednesday when I do my Cassini talk. And if you can follow us on YouTube and like this page, and if you can follow us on Facebook, Twitter, and Instagram, that would be great. If I know everyone's having a hard time at the moment, but if you feel like donating to the observatory, that would be really great, because the observatory is run by the volunteer group that was set up in '96 to help run the night sky tours. So we're able to keep the observatory alive, and it'll mean that we can do better stuff here at the observatory as well. So thanks, guys. Thank you very much for joining me tonight. We love doing this, and hopefully once this coronavirus is finished, we'll see you up at the observatory, but hopefully we'll see you a lot sooner then. Have a great night.